This presentation is part of the TI-Nfocus AP Calculus video series. In this video, we'll discuss the scoring guidelines for the 2017 AP Calculus exam, free response question AB6. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm the former AP Calculus chief reader. Here's an outline of the information presented in this video. We'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. I'll present a brief general summary for student performance on this question. Then we'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. We'll consider some common student errors, and where appropriate, I'll present some very specific scoring examples. In this problem, we start with a function f, defined by f of x is equal to the cosine of 2x plus e to the sine x. G is a differentiable function, and the table gives values of g and its derivative g prime at selected values of x. H is a function whose graph consists of 5 line segments and is shown in the given figure. In Part A, the student is asked to find the slope of the line tangent to the graph of f at x equal pi. In Part B, another function k is defined so that k of x is h of f of x, and the student is asked to find k prime of pi. In Part C, still another function m is defined to be m of x is g of minus 2x times h of x, and the student is asked to find m prime of 2. In Part D, the student is asked if there's a number c in the closed interval minus 5 to minus 3, such that g prime of c is equal to minus 4, and the student is reminded to justify the answer. Here are the scoring guidelines for this free response question. Part A was worth 2 points for finding the value of f prime of pi. Now, this doesn't mean the student was awarded only 0 or 2 points. Partial credit could be awarded. It was possible for a student to receive 1 point in this part. Part B was also worth 2 points. 1 point for finding k prime of x, and 1 point for finding k prime of pi. Part C was worth 3 points. 2 points for finding m prime of x, and 1 point for finding m prime of 2. And finally, Part D was worth 2 points. 1 point for conveying the appropriate quotient associated with the mean value theorem, and then 1 point for stating the correct justification, that is, using the mean value theorem. Here are some general comments about student performance on this problem. In Part A, most students were able to make the connection between the derivative and the slope of the tangent line. However, many students made chain rule errors, or simple sign errors, or errors in evaluating the sine of pi or the sine of 2 pi. In Part B, most students made the connection between the derivative of h, which was presented graphically, and the slope of the line tangent to the graph at the given point. However, there were some chain rule errors and, unfortunately, some arithmetic errors. In Part C, most students were able to incorporate the correct values from the table. However, there were some product rule or chain rule errors. In addition, there were some errors in finding h prime of 2 from the graph of h. And there was also some inappropriate use of notation. Remember that notational fluency is an impact, part of the curriculum framework, so it's very important for students to present correct notation. In Part D, one of the most common errors involved justifications of an incorrect answer, and students who did this often tried to invoke the intermediate value theorem. There were errors in forming the difference quotient, and some students failed to confirm the conditions that were required in order to use the mean value theorem. And there were also some insufficient verbal arguments. Let's take a closer look at each part of the scoring guidelines. Part A again was worth 2 points. 2 points for finding f prime of pi. There was an eligibility criteria in order to earn any points in Part A. The student had to present evidence of the chain rule, and there had to be no chain rule errors in order to earn any points. If a student just presented f prime of pi equals -1, that would be considered a bald answer. And a bald answer is just the answer alone where some supporting work is expected. And in this case, a bald answer received 0 out of the 2 points. Here's the general philosophy in order for the student to receive full credit or 2 out of 2 points in this part. They needed to communicate the correct chain rule in both terms and present the value of f prime of pi as -1. Here are some examples of minimal responses in which the student would receive 2 points. In the first example, even though the student has not substituted pi for x, they'd still receive 2 points. In the second example, the student didn't evaluate the trigonometric function nor the exponential function, but it's a numerical answer. And remember, final numerical answers don't need to be simplified, so the student would receive 2 points. In the third example, the student has gone a little bit farther. It's still a final numerical answer, and it doesn't need to be simplified, so the student would also receive 2 points. This is certainly minimal communication of the correct chain rule in both terms, and it's the correct answer for f prime of pi. Here are some common ways that a student could earn 1 out of the 2 points in Part A. First, they could communicate the correct chain rule in both terms, but end up with an answer for f prime of pi different from -1. Or there could be partial communication of a correct chain rule in both terms and end up with a correct answer. And here are some common examples of how a student could earn 1 out of 2 points. Here are some additional notes used in the scoring of this problem. If there was a sign error in one term with no other errors, a student could earn 1 out of the 2 points. However, if there were 2 sign errors, they'd receive 0 out of the 2 points. If there was any chain rule error at all, the student would receive 0 out of 2. And readers are very careful in looking for presentation errors. Correct mathematical notation is important. Remember notational fluency. In this problem, students may write an incorrect or ambiguous product or function argument, but present the correct answer. In this case, the student would not receive full credit for the solution. Part B was worth 2 points, and the first point was for finding a correct expression for k prime of x. There was also an eligibility requirement in this part. The student had to present evidence of the chain rule and have no chain rule errors in order to receive any points. If a student presented a bald answer, k prime of pi is equal to 1/3, they earned 0 out of the 2 points. Here are some examples of possible student responses and the score that each would receive. In the first example, the student has presented sufficient evidence of the chain rule, and there are no errors. They earn the first point. But they'd have to compute the final numerical answer in order to receive the second point. In the second example, we will read with the student who uses their incorrect numerical answer from Part A. They have presented sufficient evidence of the chain rule without any errors, and the student is eligible for the second point. We'll check their answer using f prime of pi from Part A. In the next example, the student has presented a correct numerical answer, but no evidence of the chain rule. This earns 0 points. And the final example is just a bald answer once again. No supporting work is presented. This also earns 0 points. Here's a little bit more information to summarize the second point in Part B. Remember that in order to be eligible for the second point in Part B, The student must present evidence of the chain rule with no chain rule errors. Any computation errors are assessed in the second point. And sort of a minimal response is given here. A student would receive both points for that response, well, unless there are errors presented in intermediate work. We will allow students to import incorrect numerical answers from Part A and will read with them in Part B. And another reminder that readers carefully check presentation and mathematical notation. If this is the only expression presented in Part B, notice that there is a missing right parenthesis. The presentation is incorrect, and the student would not earn any points. Part C was worth 3 points. The first 2 points were for correctly presenting an expression for m prime of x. There was an eligibility requirement in this part in order for the student to earn any points. And loosely stated, the student must present the correct product rule structure. To earn these first 2 points in Part C, the student must communicate a correct application of the product rule and the chain rule. There is always some professional judgment in scoring these problems. However, here are a couple of examples in which the student would earn the first 2 points. Note that the student has not earned the point for m prime of 2 yet. They need to evaluate these functions in order to earn that third point. Here are some examples in which a student would earn 1 out of the first 2 points. They could make a single chain rule error with no other errors. And then here are some specific examples in which they would earn 1 out of the first 2 points. And then we would read with the students to see if they would earn the third point. In order to be eligible for the third point in Part C, the student must have earned at least 1 m prime of x point. In addition, the values for g of u and g prime of u must be in the table that's given in this problem. Here are some examples of possible student responses. In the first example, the student has presented only partial communication of the product rule structure. They would receive 1 of the first 2 points and the third point, for a total of 2 points in Part C. In each of the remaining examples, the student has not conveyed the product rule structure, and therefore earned 0 points. In Part D, the first point is for presenting the correct quotient associated with the mean value theorem in the context of this problem. And really, a student must present a difference and a quotient using the endpoints of the interval -5 to -3. And here are some examples of minimal student responses that would earn this first point. If the student makes an error in evaluating their correct quotient, as shown in this example, they earn the first point, but they do not earn the second point. In this case, they are unable to reach our conclusion. Here are a couple of examples of some common presentation errors. In the first example, there are some missing parentheses here, but the student has still evaluated this expression to get a -4. They do not earn the first point, but they are eligible for the second. In the second example, there are also some missing parentheses, and in this case the student has evaluated this expression to a value of k not equal to -4. And here the student would earn 0 out of the 2 points in Part D. The second point in Part D is for the justification using the mean value theorem. To be eligible for the second point, the student must confirm in some way the conditions for the mean value theorem to apply. In other words, they must convey that g is differentiable and continuous. Now, we're given in the problem that g is differentiable, so the student must in some way convey that g is continuous also. And they must draw a conclusion. Let's suppose that the student is eligible for the second point in Part D. Here are some examples of minimal responses in order to earn the second point. In the first example, the student must include a reference to g prime of c. Just that quotient equal to -4 plus eligibility does not earn the second point. In the second example, the student has the correct quotient equal to -4. There isn't any reference to C, but they have drawn a minimal conclusion explicitly. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. There is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There's material there involving technology, calculus, and other mathematics topics.